Here's a function. This is a paraboloid, right? It's a hyperbolic paraboloid, though. So we know what the surface looks like. Here's x, here's y, and here's z. And if we freeze y, we have parabolas opening up in the x z plane. And if we freeze x, then we have parabolas opening down. So this is creating the saddle out of those. So we know what the surface looks like, but another view of the surface would be to look at its level curves. So we could look at various level curves. Maybe let's start with z equal -2. Then we have -2 equals x squared minus y squared. And that we recognize as a hyperbola. So here's x, here's y. We have our, let's see, we have our box here. When x equals 0, then y equals plus or minus the square root of 2. So when x equals 0, we have a point here at the square root of 2 and another point at negative square root of 2. Those are the two vertices of the hyperbola, and so the hyperbola goes out like this. So this is my z equal -2 level set. If we go up to z equal -1, then we have -1 equals x squared minus y squared. So this is again another hyperbola. This time when x equals 0, y squared equals 1, so y equals plus or minus 1. So my vertices just moved in a little bit from square root of 2 to 1. So they're at 1 instead of about 1.4. Okay, now these shouldn't cross. I should be a little bit more careful about that. When z equals 0, we have, let's see, I need to label this level set here. Z equals -1. When z equals 0, we have 0 equals x squared minus y squared. If you solve that, y squared equals x squared, so y equals plus or minus x. Those are the two. The line y equals x is right here. The line y equals -x is the other asymptote for the hyperbolas we've drawn already. So this is the z equals 0 level set, sort of an x. And we go up to z equals 1. We have 1 equals x squared minus y squared. That's the same as before, but the roles of x and y have been switched, right? Before, if we multiplied this through, we had y squared minus x squared equals +1. Now we have x squared minus y squared equals +1. So we get here at +1 hyperbolas that go this way. Okay, and then when z equals 2, then we have 2 equals x squared minus y squared. Notice that when y is 0, x equals plus or minus root 2, so we have two vertices here and here. Okay, so that creates our vertices. Now we could go ahead and use Maple to plot these. We'd get a much cleaner plot. Let me just do that really quick. Let's see, do our same 5 plots, but we just need to change our equation. This time it was x squared minus y squared. So I'm going to change all these to x squared minus y squared. And then the level sets I chose were z equal -2, z equal -1, z equal 0, z equal 1, and z equal 2. Let's display all those plots together. Oh, good. So we get this plot. Oops. Plot that again. Just trying to shrink my plot down a little bit. Yeah, so we see our level sets. This was the -2, and then the -1, and then the 0. This little box isn't really there. It's just a little trouble that Maple was having because it had to do an implicit plot. Saw these points nearby and thought, oh, might as well collect those up with a curve, but it's not really what's happening. It's just an x. We know that from looking at the actual algebra of the situation. Okay, so think of this as, you sort of see the mountain pass in the hyperboloid, right? So you come up through the saddle and back down, right? On either side of you are hills going up and up and up.